Welcome back, dear explorers of the cosmos. In this video, we'll be journeying into the realm of the infinitesimally small, the quantum world. The year 2023 was a pivotal one for particle physics, with discoveries that left us awestruck and reaffirmed our fascination with the universe's hidden intricacies. From the unveiling of the enigmatic goddess particle to the detection of ghostly neutrinos, we witnessed a quantum revolution that challenged our understanding of the cosmos. So fasten your seatbelts, because we're about to dive into the biggest particle physics stories from 2023. Prepare to have your mind blown. Have you ever wondered about the mysteries of the universe? Well, 2023 has been an exciting year for cosmic revelations. Imagine a cosmic ray particle so powerful it's named after Amaterasu, the goddess particle. This new entrant to the particle physics stage boasts a staggering 240 exa-electron volts of energy. That's ultra-relativistic high-energy territory for all our science enthusiasts out there. But here's the real kicker. Amaterasu originates from the direction of the local void. For those who are not aware, the local void is a vast empty space in our cosmic neighborhood. Its very emptiness makes it an unlikely source of such high-energy particles, adding an air of mystery to our understanding of these energetic particles. So, what does this mean for our understanding of cosmic rays? Simply put, it has broadened the horizons of our curiosity, posing more questions than answers. The birth of Amaterasu has given us more questions than answers, making the universe even more intriguing. From the mysteries of cosmic rays, we dive into the elusive world of neutrinos. This year, the IceCube Neutrino Observatory delivered a revelation that shook our understanding of these ghostly particles. It seems our very own Milky Way is producing neutrinos, challenging the previous belief that only distant galaxies were their birthplaces. So, why the fuss about neutrinos? Often referred to as ghost particles, these subatomic entities are renowned for their elusive nature. They barely interact with normal matter, making them notoriously difficult to detect. Imagine billions of these ghost particles passing through you every second, undetected and unnoticed. It's a bit like trying to catch smoke with your bare hands. While we're still far from fully understanding these phantom particles, each new revelation adds another piece to the puzzle. With each piece, we get one step closer to understanding the universe's most elusive occupants. We're far from understanding the ghostly neutrinos, but each discovery puts a piece into the puzzle. From ghost particles, we now turn our attention to the rhythm of the cosmos. Picture this, a pulsar, a celestial object that emits regular pulses of radiation, is tucked away about 1,000 light-years away in the Vela constellation. This year it caught the attention of researchers around the globe when it produced the most energetic gamma-ray photons we've ever detected. This pulsar, this cosmic lighthouse, is pulsating with energy that surpasses the energy of typical solar flare photons by over 2 million times. Imagine the kind of cosmic symphony this pulsar is conducting. By studying these gamma-ray photons, we can better understand the nature of these pulsars and the incredibly high-energy processes they undergo. Each pulsar beat is a note in a grand cosmic melody, a melody that is continually revealing new insights about the universe we inhabit. The pulsar's beat reverberates through the cosmos, reminding us of the energy that lies beyond our sight. Next, we traverse galaxies to witness a cosmic spectacle. Picture the brightest gamma-ray burst ever observed, a celestial event so powerful it was named the Boat. We're not talking about a small dinghy, but a vessel of cosmic energy, its radiant light cutting through the vast expanse of space. This boat didn't set sail from a nearby port. Its origin? A galaxy nestled behind the Milky Way. Despite the considerable distance, its effects were felt right here on Earth. The boat's intense radiation disturbed the upper layer of our atmosphere, specifically the ionosphere. This extraordinary observation of the boat's gamma-ray burst is a beacon illuminating our understanding of these cosmic phenomena. It highlights the sheer power that resides in distant galaxies, power that can ripple across the universe and stir the atmosphere of our own planet. As we continue to peer into the cosmos, we keep unearthing new mysteries, each discovery a stepping stone in our journey of understanding. The boat has set sail, leaving us in awe of the power that lies within distant galaxies. From the power of gamma-ray bursts, we delve into the world of antimatter. Imagine a mirror universe where everything is the opposite. Instead of matter, there's antimatter. But does this mirrored substance act differently under gravity's pull? Thanks to the geniuses at CERN, we now know the answer is a resounding no. In a major experiment, CERN confirmed that antimatter responds to gravity just the same as normal matter. This might not sound like a big deal, but it's an important piece of the puzzle in our understanding of the universe. It means our theories of gravity, based on Einstein's general relativity, hold up even in the bizarre world of antimatter. This has far-reaching implications, reinforcing our understanding of how the universe works at its most fundamental level. It's a reminder that even in a universe full of weird and wonderful phenomena, some rules hold true. The dance of matter and antimatter continues, guided by the invisible hand of gravity. Now let's journey to the heart of darkness, the enigmatic black hole. In the annals of particle physics, this past year witnessed an astounding discovery. It turns out black holes, those cosmic devourers of light and matter, are also factories of elusive neutrinos. These ghost particles, as they're often called, rain down on Earth in a constant shower, and scientists have now traced some of them back to the swirling, high-energy plasma that surrounds black holes. Imagine a cauldron of matter, heated to unimaginable temperatures, churning and twisting around the event horizon of a black hole. The intense energy in this environment triggers a cascade of particle transformations, creating a steady stream of neutrinos. These tiny particles then zip across the cosmos, virtually unimpeded until they reach our detectors here on Earth. So it seems in the heart of darkness we find a factory of ghost particles, adding to the enigma that is the black hole. From black holes, we delve into the elusive world of dark matter. It's a realm of cosmic mysteries that has kept scientists on their toes for decades. This past year, the super-cryogenic Dark Matter Search collaboration has made significant strides. They've provided tighter constraints on the nature of dark matter, helping us to narrow down its potential characteristics. Imagine trying to piece together a cosmic jigsaw puzzle, but you're not sure what the final picture is supposed to look like. That's what it's like working with dark matter. These constraints are like getting a few key pieces of that puzzle. They don't give us the whole picture, but they help us start to see some patterns and shapes. These strides forward are exciting, not just for the scientists doing the work, but for all of us. They're unraveling the mysteries of the universe bit by bit. The search for dark matter continues, with each step bringing us closer to the truth. Next, we explore a new force of nature associated with dark matter. In the vast cosmic theatre, where light and matter perform their intricate ballet, a new player enters the stage, the dark photon. This hypothetical particle, a sibling of the familiar photon that brings us sunshine and rainbows, is thought to be a messenger from the realm of the unseen, the dark matter that permeates our universe. The concept of dark photons brings a fascinating twist to the dark matter conundrum. If they exist, these elusive particles could interact with regular matter, opening up new avenues for their detection. Theoretical physicists are now crafting ingenious ways to catch a glimpse of these shadowy messengers using cutting-edge experiments and advanced simulations. In this grand cosmic puzzle, every piece we discover reshapes our understanding. In the realm of darkness, we might find a new force of nature, challenging our understanding of the universe. From dark photons, we delve deeper into the world of dark matter. This year, we witnessed a bold proposal that suggests a new layer of complexity in our understanding of dark matter. Imagine a periodic table, not of elements as we know them, but of different species of dark matter particles, each with its own unique interactions and properties. This is the idea of a dark periodic table. It's a concept that extends our understanding of regular matter to the elusive, unseen dark matter that fills our universe. The implications are huge. If dark atoms form in galaxies, as this proposal suggests, their interactions might have observable effects on star production. We could see fluctuations in the rate at which stars form, or even unexpected patterns in their distribution. The dark matter realm might be more complex than we thought, with a whole periodic table waiting to be discovered. Now let's travel back in time to the universe's early moments after the Big Bang. Picture this, a chaotic cosmic nursery bubbling with energy and potential. This is the setting for one of 2023's most mind-blowing revelations in particle physics, the discovery of bubbletrons. These aren't your everyday bubbles. Bubbletrons are particle accelerators formed in the tumultuous period following the Big Bang. You see, our universe was a hot, dense soup of particles. As the universe cooled, forces began to split, creating bubbles. Now, these bubbles weren't just floating around, they were colliding, and these collisions had a profound effect. These bubbletron collisions could have shaped the particles we observe today. Like cosmic blacksmiths, they might have hammered and molded elementary particles in the universe's fiery forge. This discovery opens up a whole new area of study, offering fresh insights into the origins of our universe. The universe's infancy might hold the key to understanding the particles we see today, and bubbletrons are leading the way. Finally, we turn our gaze to the star that gives us life, our sun. A celestial body we often take for granted, yet it's a powerhouse of energy and a source of unending fascination for astronomers. This year, using the high-altitude Water Cherenkov Observatory, a new discovery has been made. Scientists have found that the sun is capable of generating excess gamma rays. Gamma rays, the most energetic form of light, have long been associated with the most explosive and energetic phenomena in the sky. That our sun, a relatively calm star, can produce such an excess is both surprising and exciting. It highlights the sun's energetic nature and opens up a new avenue for the exploration of solar physics. What does this mean for us? It brings us a step closer to understanding the inner workings of our sun. As we delve deeper into this discovery, we realize that our sun, a familiar sight, still holds mysteries that continue to fascinate us. From the smallest particles to the vast cosmos, 2023 has been a year of discovery. We've journeyed from the discovery of Amaterasu, a new cosmic ray particle, to the revelation of our own Milky Way, producing elusive ghost particles. We've felt the beat of the most energetic gamma-ray photons from a distant pulsar and witnessed the brightest gamma-ray burst, the boat, causing ripples in our atmosphere. We've reaffirmed that antimatter succumbs to gravity just like normal matter and learned that giant black holes are an unexpected source of neutrinos. Our understanding of dark matter has been refined, and we've pondered the existence of a new force of nature and a dark periodic table. We've delved into the early universe with bubbletrons and discovered our sun's surprising ability to generate excess gamma rays. As we look forward to 2024, we can only imagine what new discoveries await us in the fascinating world of particle physics. Thank you for joining us on this incredible journey through the mind-blowing discoveries of 2023. As we venture into the new year, we invite you to stay with us as we continue to unravel the mysteries of the cosmos. Don't forget to subscribe to the Space Origins YouTube channel for more fascinating and exciting content. Your support and interest are what keep us going. Remember, the universe is teeming with mysteries waiting to be discovered. Stay curious, keep exploring, and join us again as the journey with Space Origins continues.